Hello and welcome. My name is David Villar. I do teach pharmacology at a veterinary school in central Colombia, and I have the pleasure of being here with you, and we'll be talking about the environmental and community impacts of mercury pollution from artisanal gold exploration in Colombia. The objectives of this presentation are briefly outlined on this slide. I know it's a little bit dense, but if you have the patience to stay all the way up to the end, it summarizes everything that we'll be covering throughout the presentation, and we're going to divide it in two parts. First, we'll highlight the environmental consequences of gold exploration in Colombia and why is mercury being used for artisanal gold mining. And secondly, we'll be talking about the human health consequences of using mercury for gold extraction. And that exposure is taking place primarily through direct inhalation. That's how most miners become sick. But it can also be through an indirect contact, and that's we'll be showing a few examples. We'll be also telling you about a couple of human epidemics that have occurred from exposure to organic mercury compounds, and also towards the end we'll be basically telling you a little bit about how regulatory agencies like FDA establish guidelines for safe consumption of fish, how they do their risk estimates, and in Colombia, what are some of the risks that you're taking when you're eating fish from some of the rivers or coastlines also. There are two different types of gold exploration. We can divide it into industrial gold mining. That's the type of mining that is done by large multinational companies, very wealthy people, and it tends to benefit just a few of them. And usually, many times they operate with total impunity in undeveloped countries, and with the blessings of their countries. And as you can see, they live pretty desert-like areas. So if you really had a dream of ever going to the moon, you may fulfill your dream. You could maybe just come up to one of these sites and enjoy a moon-like landscape without really needing to get on a spaceship to do so. The other thing that these companies leave behind are these gorgeous looking tailing ponds that are basically just a juicy cocktail of acid water, heavy metals, cyanide, that in this case we have cyanide barrels that were left inadvertently to float here on that murky water, and if any living creature were to come even close to these ponds and dare to take a sip out of that water, will no doubt endanger itself, its life, but we might even manage to kill them. The other type of gold exploration is artisanal gold mining. It's done by mostly poor people that we can call it a survival subsistence economy, and it benefits obviously more population, and it's by no means less evil than its counterpart, industrial companies. But if we were to put on a scale the size of the devastation that is created by the two different types of exploration, artisanal would not even come close to industrial mining as far as the total area that is devastated and deforested by mining. And unfortunately, that's taking place in Colombia, and there we can name several dozens of these huge companies. Half of them are Canadian, and they don't have a very good reputation when it comes to the protection of the landscape and the ecosystems. Okay, now let's bring up an example of what we could call an aquatic ecocide done by artisanal miners, and it's taking place in the Dagua River, which is located here in this red zone of the Colombian map. It drains into the Pacific Ocean, and basically this was kind of a nice, pristine looking river before 2009, at which point gold was discovered in April, and in just a matter of a few months, in November, there were 8,000 gold prospectors settled on the riverbanks in shacks. And I don't know if you might be able to pinpoint, but these are bulldozers. About 300 of them were counted from the air, and working day and night, turning the river bed in and out and changing all the river course. Here we have another aerial view of the river. There are about 22 kilometers altogether of unrecognizable river course. You can see it full of potholes. You can hardly tell where the main course of the river is no longer. Here we have another view from the air, and here is a close-up view of operations on the ground. And here's some of those potholes that we were seeing from the air. And as you can imagine, working safety conditions are not state-of-the-art. But I bet you that every member of the family that can wear rubber boots probably gets involved in that operation. Everyone except for Uncle Sam that should have intervened and put an end to that madness before it even started. There are a lot of tragedies taking place in Colombia, many avalanches and landslides, and as you can just imagine on this particular scenario, we have a bunch of people down here, and look at this part of the riverbank that was bulldozed. This could collapse and basically bury all these folks in a split second, and they would probably just blame the wrath of Mother Nature, as they usually do on the news when those events take place. Why is mercury being used to separate gold from the river sediments? Well, just basic chemistry. Mercury has a very high affinity to bind certain precious metals, gold, one of them, and basically what they're doing here is they're using elemental mercury on this pan to mix it with the sediment, or they lay it out here on these sluice boxes. They shake it all up, and when the mercury binds gold, it will form an amalgam, and you can see the colored gold on this amalgam here, kind of sparkling and all shiny. It's kind of wet, but if you were to put that amalgam on a handkerchief and squeeze it, you would drain off, or the excess mercury would run off, and you would be left with a solid pearl. And you can take that pearl, if you have any sophisticated means of burning it, like they do here. They have some type of an exhaust for fumes. Or if you want to delight all your family, you can do it in the open air and have everybody just gather along that pan and basically heat it up with a blowtorch, and so that all the people can enjoy the magic of mercury being evaporated and the gold staying behind, all shiny, sparkling, and ready to go into someone's jewelry box or basement of a central bank. What are the potential consequences to the ecosystem of the Daguer River? I have highlighted in the slide river floodings, because that's a major tragedy that is occurring year after year in Colombia. And for example, in 2010 there were about 2 million people with severe housing damage, particularly around the Magdalena Delta River. And most of that flooding is taking place because of the widespread deforestation that is occurring in all the watersheds throughout Colombia. And but in this particular case of the Daguer River, we could say that the sedimentation downstream is obviously causing the bottom of the rivers to be lower, and whenever the storm comes in, the water level will rise, the river will easily overflow and create flooding situations in the area. The problem is so radical that they have to dredge the Buenaventura harbor just about every day, because otherwise the ships are not able to come in and out of the city. Another of the consequences that I have included from the destruction of that river is the loss of fishing, and obviously the water quality, and the mercury that is not being recovered and is end up in the water column. And eventually that mercury, although it's elemental and it's not easily taken up by river organisms, when it ends up in the sediments, it will convert to methyl mercury, which is it's the most toxic form of mercury, and it's easily moved from one part of the food web to the next, and the other consequence is that all those potholes are excellent breeding grounds for mosquitoes, and that's going to create mosquito swarms. And in those particular areas, dengue and malaria are two deadly diseases that are that take a heavy toll on the population also. So let's just remind you where we are on the presentation. We have said a few things about the environmental consequences, and now we're going to move on into the human health consequences of using mercury. And I mentioned that Colombia, has at the moment the most heavily polluted mercury towns in the world. We have what's called hotspots areas, and I'm going to touch on those on the next few minutes. So before I do so, let's say a few things about the toxicity and the importance of mercury. As you can see on this slide, mercury is a priority for action by the United Nations campaigns, and if you go into their website, you'll see that they have different modules. On module number 3 is specific for addressing problems related to mercury use in artisanal and small scale gold mining. What is the situation in Colombia with regards to mercury going into the being improperly used? According to the report by the United Nations of 2010, they stated that Colombia is currently one of the world's top mercury polluters, with 50 to 100 metric tons of mercury lost annually in the process of capturing gold. And so we can say that Colombia is the world leading per capita emitter of mercury, and most of that is related obviously to the process of exploiting gold. So guess what took place a few years back? They nominated President Álvaro Uribe for the Gold Mercury Award winner of 2009, and you have here all the delegates of that prestigious event giving him the gold statue here. And I might be I might be the only one that sees the world upside down, but if you can explain that one to me, I'd be most obliged. Personally, I had a very high opinion of President Uribe. I thought he did well in many areas, but when you start seeing what's cooking behind the scenes, as far as permissions for many of these mining operations to proceed, I don't think he deserves this award by any means. Now, let's say a few things about the toxicity of mercury. And if you've read a little bit or heard about a little bit about it, it's highly dependent on the chemical species. As any other metals, mercury is not destroyed; it's simply converted from one form into another. And of the different forms that it can adopt, we have the inorganic forms of mercury. One of those is elemental or pure mercury, which is a liquid, but it can easily evaporate, and in its vapor form is very toxic because it can readily go into the central nervous system. And the other forms of inorganic mercury are its salts, either in divalent or monovalent form. And then finally we have the organic or carbon-bound forms of mercury. And as you can see here, particularly methyl mercury in fish accounts for many epidemics, and we'll briefly say a few things about those later on. As you can see, methyl mercury can also have the potential to go into the central nervous system, which accounts for most of the toxicity of mercury in mammalian species. So, if we were to say a few things about how is the species of mercury affecting the toxicity, we could say that inorganic salts have a kind of a corrosive type effect, just like arsenic. They will damage cells that they come in direct contact with. So if let's assume we have an oral exposure, the first thing you would see is severe damage to all the gastrointestinal tract, which we have abbreviated here. And even if it's if not readily absorbed, unless there is severe damage, whatever goes in will still be able to damage the vascular systems, and particularly the renal system, because the kidney will accumulate a lot of that mercury and will concentrate it with regards to more than any other tissue in the body. So those will be the two most sensitive organs that we would expect to see damage from exposure to inorganic salts. With regards to elemental mercury, the liquid form is not very toxic. If you were to break down a thermometer, let's say, and or play with that quicksilver, they call, because it moves very fast, that form of mercury doesn't really penetrate very well the skin or the gastrointestinal tract. So it's unlikely that you will get a significant dosage to get sick from it. However, if that mercury were to be evaporated and you inhale it, which is the most common scenario, how miners are exposed, they will get, if the dose is high enough, they'll get a severe lung damage. They'll get a pneumonitis with severe chest pains, coughing, high fever, and they might die within a few days. And if they don't die, that form of mercury will metabolize into its divalent or inorganic form, which, as we said before, it's particularly toxic for the kidneys. Now, elemental mercury in its vapor form, on a low dose exposure and continuously, will particularly target the brain and to a less extent the kidney. But this is going to be as we'll see later, this is going to be the most common course of poisoning in miners. They'll develop central nervous problems, and some of those will also develop kidney problems. And finally, the organic form of mercury. This is the way we are exposed when we eat fish. This also has a easy way of finding its way into the brain. It penetrates membranes easy, and as you can see here, a little bit at a time, eventually will build up to a high mountain and create central nervous system problems. Okay, what is the fate of mercury in the aquatic systems? This is, as you can see, not a very scientific cartoon. It's meant for a general public, but anyway, regardless of the type of the species of mercury and how it finds its ways into the aquatic system, one way or the other, it's gonna end up finding its way into the food web. And usually, prior to that, you need conversion of most of that mercury into methyl mercury, which is the most bioavailable form of mercury, easily to penetrate in any living creature. And as you can see here, it tends to build up on the food web. So those fish that are older will build up higher concentrations of mercury, and we have that same theme represented here. Grandpa fish will have a lot higher levels of mercury, all the way up to its eyebrows, and the age of the fish is usually related to their size. So bigger fish tend to be older, and therefore will have had more time to retain mercury throughout their lifespan. And that also there is another component to how much mercury they'll have, and that is their position on the food web. carnivorous fish will have higher levels than planktivores, for example. Mercury advisories. Just about any developed country that has a lot of recreational fishing and may have these mercury advisories. And basically what they do is they will, depending on which type of fish and which category of sensitivity you fall in, is not the same an adult as an infant or as a pregnant woman. They'll tell you how much fish you can eat and still be on the below the threshold danger zone. And for example, in the United States, if they list a group as 4, they tell you not to eat that particular fish, and that, as I say, that has to do with the total exposure will not only depend on how much concentration is on that fish, but how much of that fish you're eating also. In general, if the fish is has higher than 1 part per million, they tell you not to ingest it. Okay, just as a reminder of where we are on the presentation, we've talked about environmental consequences, a little bit about the mercury forms of chemical forms, a little bit about which target organs affects depending on the chemical species, and now we're going to try to tell you, bring it down to earth and say a few things about the areas of Colombia that are hotspots areas. This is a report that was put out by a professor from the University of British Columbia, Marcelo Vega, and he made a couple of visits to several towns, that mining towns in Antioquia, and the report reads the world's most polluted place by mercury, impressions from 2 field trips. Now, what are those places? 2 particular towns, one called Remedios and the other one Segovia. These are populations of 5 and 25,000 people. They have about 323 in tables roasting balls of amalgam and releasing between 50 and 100 metric tons of mercury a year. And they do it right there in the middle of the residential area. That they burn it right there, so it all ends up in the streets and contaminating the houses and everything, the air, everything on those towns. There are numerous stories of peoples with signs of chronic and acute poisoning, and fortunately those stories don't really make it out of local websites and newspapers. This is a nice report that was sent to me by this gentleman, Paul Cordy. He's a PhD candidate out of the University of British Columbia, and he spent 2 years in Segovia, and basically taking measurements of mercury in just about every street of the town on a weekly basis throughout the year. And if you can see these triangles here, all these dots represent establishments where mercury is being burned, or amalgam is being burned, sorry. As you can see, it's right in the middle of the residential area, and this is for 2010, this is for 2011, and the colors represent how much concentration was measured in the air on average throughout that year. And if you see the red zones here, those red zones are above the threshold that has been established by World Health Organization as a danger zone. So a lot of people in this town are breathing lots of mercury day and night. This is the conclusion from the United Nations report on the situation in those particular towns, and I'm not going to read it, but I'm just putting out here if you want to take the time. And I thought it would be interesting to at least mention something about where the mercury that Colombia is using comes from, because many of the places that are exporting mercury into Colombia probably have very strict regulations as far as proper disposal of mercury. They probably have advisories to protect their own people, and yet here we have a list of all the countries that are shipping tons of mercury into Colombia: Netherlands, Spain, Mexico, Germany, US. Okay, and now how I thought this is probably the most interesting part of the presentation, and it deals with how agencies go about making their risk assessments. In other words, how do they come up with a reference value or a guideline to say, okay, you're being exposed to a lot of mercury, or the levels that you're being exposed are safe and you're not going to develop problems. Now that's basically that's what would be called doing a risk assessment evaluation, and basically you're determining the likelihood that a particular hazard or threat will occur. And I'm going to set the example for vapors of mercury and how they go about doing those safe risk assessments, and later we'll do it for fish mercury that is ingested through fish consumption. So the information that we need to come up with a risk assessment are basically you need to know the about the toxicity of the compound that you're interested. Those studies usually come from dose response curves, and if those are usually not in the case of mercury, we have a lot of data from humans, and basically we're not going to use a dose response curve. We're going to use what's called the lowest observed adverse effect level and the no observed effect level to establish what dose might cause problems on a long-term basis. And the other piece of information that you need to come up with a risk assessment is to know how much the people needs to be exposed as far as quantity, how frequent, whether it's just 40 hours a week or every day, every hour of the day throughout 7 days a week, and the duration of the exposure, whether it's just a few years or during your lifetime. So, to come up with a risk assessment for chronic mercury vapor exposure, what the endpoint that is being used to determine whether you're intoxicated is the most sensitive endpoint that will happen with first when you're exposed to mercury, and those are intention tremors, and I'll say a little bit about those later. Now, with regards to the exposure, they used data from workers that were working in 3 different industries that were making thermometers, lamps, some chloralkali plants, and they had been exposed to mercury vapors to an average of 26 micrograms per cubic meter with a frequency of 8 hours a day and for 15 years. Now, you might wonder how many agencies are doing risk assessments. Well, lots of them, and I have listed probably the most important ones here for your delightment. Some of them are regulatory. In other words, they issue standards, and when you have a standard, it means it's a level that can be enforced, and it's the industries are have to obey, and or they can issue guidelines. In other words, they can just give advice or recommendations as to what is a safe dose. So with some of those regulatory agencies are, for example, the Food and Drug Administration, and I'm just gonna, they do a lot of things, but for example, if you want to find what would be a tolerable daily intake of mercury in food, you could go to the FDA website, and basically this level, it's how much you can ingest every day throughout the rest of your life and still be well below the danger zone. Okay, I will not like, there is a huge misconception among the public that they think that if you go anywhere below above the TDE, tolerable daily intake, you're going to get problems, and that's not the case, because there is a lot of safety factors that have been built to come up with that level. So that's I'll in a few minutes I'll show you how they calculate these guidelines. Another agency is the Consumer Product and Safety Commission. Another one is the EPA. Now, EPA does not regulate food, but they regulate everything else. And so they come up with what's called a reference concentration for mercury in air. If this was not air, maybe they would have a reference dose instead of concentration, which is the same as the tolerable daily intake. Basically, it tells you how much you can be exposed for every day for the rest of your life, and still well below the danger zone. Another one is the Occupational Safety and Health Administration. Now, if you work, let's say, in a plant that makes lamps or thermometers, they'll probably the OSHA will have established what's called permissible exposure levels in a time-weighted average. In other words, that's the level that you can be exposed for 40 hours a week, which is the regular working hours that you're likely to be exposed to mercury. And they'll also come up, for example, with short-term exposure limits and ceiling limits. And these are mandatory. These are levels that the industry has to obey. They cannot allow workers to be exposed to anything different than what the OSHA tells them that they can be exposed to. And then we have the non-regulatory agencies, the Agency for Toxic Substances and Disease Registry, and which is, as you can read there, dependent on the Department of Health and Human Services. And if you want to know anything about mercury, there is almost a 600-page long document, which it's, as you can see here, toxic profile for mercury, and this is kind of the Bible for mercury. If you want to know every single study that has been ever published and what are the basically the guidelines for exposure to in any form and shape, you can go there and you'll probably find it. And I'm gonna use them to illustrate how they calculate what's called the minimal risk levels for mercury exposure. And finally, another non-regulatory agencies. We have the American Conference of Government Industrial Hygienists. Here, if you see TLV, that's threshold limit values. We have the National Institute for Occupational Safety and Health. They have their own reference value, which is the recommended exposure limits. And then they have, you can find also a lot of information on the International Agency for Research on Cancer. And these are, as you can see, non-regulatory agencies. Okay, so let's see how this agency, the Agency for Toxic Substances and Disease Registry, come up with the minimal risk levels for chronic exposure to mercury vapors. They use that one study in which they use that one study that they found out what's the lowest observed adverse effect level in an occupational setting. That is, workers that were working and exposed every day for 8 hours a day and 5 days a week throughout their working life. And basically, many of these workers, they showed that they have tremors, and that's usually the most sensitive endpoint that you will detect early if you have any problems due to chronic mercury exposure, okay, through the air. So they know that that level is 26 micrograms per cubic meter. And as you can see, it's on a time-weighted average. In other words, that's the average that the workers were exposed for 15 years, and for 40 hours a week. Now, if you want to extrapolate that to the common scenario of, for example, let's say people living in Segovia, they're breathing obviously day and night, 7 days a week. So you have to divide that number by the rest of the hours of the week. And when you divide 26 by 4.2, you come up with a value of 4.8 micrograms per cubic meter. In other words, if you're breathing air containing this much mercury throughout the entire week, you're going to be exposed to the same dose of mercury as these workers were exposed to this when they were breathing air containing 26 micrograms per cubic meter for only 40 hours a week. Alright, so that's the first conversion that comes into place. Now the second one they're going to come up with a minimal risk level in the case of this agency, and if it is the EPA, they'll use a reference concentration. Basically, these levels, as you can see, they're far way below the dose response curve. Okay, and basically what they want to know, what they do here is they divide by what's called an uncertainty factors, and most of the time these are just one, sometimes two orders of magnitude below the dose response curve. So basically, in this particular case, they divide it by 4.8 by 30 to account for individual variation, and by 3 because they were using the lowest observed adverse effect level instead of the dose that doesn't cause any effect. So they came up with a number which is 0.2 micrograms per cubic meter, and for the EPA uses 0.3 micrograms per cubic meter. So now those are, if you want, reference values, and as I said before, people think that is a threshold value. That's not correct. If you're exposed to more than this value, it doesn't necessarily mean you're going to develop problems. But public officials like to have a value that they say, okay, below this point, you're on the safe. You're out of the danger zone, so to speak. I'm not sure if I made that clear, but let's see. For example, if we were to extrapolate those numbers to the real situation that is taking place in Segovia, we said that there are many areas of the town that the concentrations in air are between 1,000 and 10,000 nanograms per cubic meter. That's the same as 1 to 10 micrograms per cubic meter. And as I said before, the lowest concentration that people will develop intention tremors is 4.8. So basically, we are within the range of the concentrations where people will start develop toxicity due to mercury exposure. And here I have listed what, as you can see, the reference concentration that the agencies use is 0.2. It's well below the lowest observed adverse effect level of 4.8. Now there is one interesting thing that it doesn't make it out on the scientific media or anywhere else, but if you read the story of many of these miners, the first thing they complain is that they can't drink their soup without spilling it all over the table. And that's because intention tremors, what it is, you try to initiate an action and all of a sudden you start shaking. So if you're drinking your soup, before you get it to the mouth, all the content of that tablespoon will be spilled all over the table. And that's what that's one of the main problems that, or the first problems that these miners will complain about, that they need a babysitter to eat at least soup. Okay, now this is this histogram came out of the EPA website, and here you have the list of all those agencies that I've talked about before, and their if you want, their action levels. And so here we have health numbers, and here we have regulatory and advisory numbers. It's regulatory if it is, for example, OSHA, which is here. And with health numbers, as you can see, they use that one study in which they reported 25 micrograms per cubic meter as the lowest concentration that will produce toxicity on the long term. And as you can see, the EPA uses the reference concentration way below, but as you can see, they have built in a huge safety factor here, and it's 0.3 micrograms per cubic meter. Okay, now let's move on to the next part. How do they go about making studies on those populations of miners? If you want to design a study whether there are people suffering from mercury poisoning in these mining towns, you don't need to do much work. Well, you need to do a lot of work, but basically all the details on how to set up the study are in this booklet here, and this is the first page, as you can see, and these are basically these are the protocols for environmental and health assessments of mercury release by artisanal and small-scale gold miners. Now, in a nutshell, what does that type of a study entails? You're gonna go out there and you're gonna collect information. What type of information? A lot of information. But basically, when it comes down to the information that goes into the equation, so to speak, without accounting for all the confounding factors, whether the people drink, smoke, have Parkinson's, for example. Basically, you're going to collect a lot of medical information. You're going to submit those people to clinical and medical exams, and you're going to come up with a medical sum score, and you're also going to take biological samples, call it from either hair, urine, blood, and you're going to establish what's called a you're going to, depending on how much mercury is found on those samples, you're going to put those individuals into different categories, and when you combine the amount of mercury in that individual with the medical scores, you can decide whether that individual is suffering from chronic mercury poisoning or not. Here you have the table that basically summarizes all the medical exams that you're going to be collecting, and in the end you're going to come with a total score, and probably shaking or tremors is somewhere here. Tremors at work. That's what I was saying, intention tremors. Some other things that you will notice on these miners is that they get really softy gums, and their teeth come loose, and they have discoloration of the gums. They have ataxia, and some other problems that are listed on that table. So here you have the threshold limits for mercury in blood, urine, and hair, and as you can see, you're going to put that on a different category depending on how much you find, and when you combine those results with the medical score, you're going to decide whether that individual is intoxicated or not. And this is some of the other information that you're going to collect on that study. Obviously, you need some inclusion and exclusion criteria. Okay, and let's we're coming close to the end. Um, we talked about the direct human exposure through inhalation, and now we'll say a few things about indirect human exposure through fish consumption, and we'll refer to some of those epidemics that have taken place, and the most or the best known of all of them is called Minamata disease, and basically for all those people that are doing environmental studies and want to pick up a disease of what happens when we're not responsible, this is the most serious disease that has resulted from the environmental contamination caused by wastewater this being discharged directly into a bay. And in this particular case, the factory was producing acetaldehyde and was discharging methyl mercury, which is ready to go into any aquatic organism or marine life that lives on that bay. And obviously, if it is fish, clams, oysters, it's going to build up very quickly on those organisms, and the people will that are eating those items will also accumulate dangerous concentrations of methyl mercury in no time. Here you have the pathological and the clinical features of Minamata disease. Methyl mercury has predilection for certain areas of the brain. One of those is the cerebellum, and you can see here on this kind of picture that there are a lot of tissue that is missing in this cerebellum here. I'm not sure if that's the cerebellum or the brain cortex, but anyway, I can tell you this whole area was supposed to be filling with neurons and be as dark as this other one below. And the clinical features, basically, these people develop one of the first signs that will appear with methyl mercury is an altered sensation, and they call that paresthesia. Basically, you get a tingling feeling, like on the extremities, like if they were poking you with needles, kind of like the sensation that we have when we fall asleep on an arm, for example, and you haven't moved it for a long time. The other things that that will progress into ataxia, and the people will develop impairment of the vision, hearing, speech. And how about the fetuses? Well, the fetuses of those pregnant women are still more sensitive than the adults, and because they still don't have a fully grown brain, they won't get much damage on that brain. But the problem is that the brain will not grow either. In other words, the neurons will not be there, so they're going to be born with severe neurological deficits, as you can imagine, from having a hypoplasia of that brain. And these are just a list of signs that those babies will have. The mother might not have experienced poisoning from methyl mercury, but will give birth to babies that are completely retarded, that have ataxia, that have deformities, just a real tragedy. So, coming close to an end, if you bear with me, we're going to talk about fish advisories for mercury. And as you can read on this slide, we have the tolerable weekly intake for mercury, and it's set at 0.3 milligrams per person. That's according to the World Health Organization. So the two questions are why are the advices on a weekly instead of a daily basis? And the second is, how do they come up with these values, right? Well, to answer the first question, we're going to look at this kind of a diagram that we have here, or if you want, basically this on this figure we have the days on the down here on the x-axis, and we have the dose of methyl mercury up here on the y-axis. Okay, and here we have different lines. Okay, and as you can see, down on every line you have the amount of methyl mercury that is on that particular meal and how much of that meal you're consuming. So let's assume that we're ingesting fish that have 10 parts per million right here, and we were ingesting 100 grams a day of that particular fish. As you can see, you're not going to develop a toxic dose right away. You need several days, and in this particular case you need to ingest that item for at least 2 years to reach a toxic dose. Basically the dose makes the poison, right? So we need to reach a toxic dose of 100 milligrams per person before we develop the first sign of methyl mercury poisoning, which is, as I said, part of that tingling feeling that you develop, and in medical terms it's called paresthesias. And down here we have the FDA limit of 1 part per million. Now, why does mercury rise so slowly? Well, it takes about 4 to 5 half-lives to equilibrate the if you were to ingest the same amount every day of a compound that has a half-life like mercury of 50 days, right? It would take from 4 to 5 half-lives before you reach the equilibrium between what's going in and what's going out. So basically mercury is building up, and it gets to a point that what goes in is the same as what goes out, and therefore stays stable. So with the case of methyl mercury, as you can see, it's going to take several months to build up a toxic dose, right? If you were to ingest, let's say, a fish that has 10 parts per million, that's not enough to cause problems. You're going to need to take many of those fish for several months before you start developing signs. So that kind of answers the first question, why on a weekly basis? Because mercury has such a long half-life that the fluctuations that you're going to see from one day to the next are very slow, right? So basically what you're going to ingest, it would be the same ingesting a little bit for every day for a week as having that same amount ingested in just one day. The other question that I was asking is, how do they come up with these values? Okay, and we're going to answer that question here. How do they derive a tolerable exposure of methyl mercury? Well, they went back to the literature and they pick up this report from 1998. They used 700 mother-infant pairs that were consuming 12 fish meals a week. This is a population that doesn't drink much alcohol and tobacco, so there are two confounding factors that don't come into the equation. And they use maternal hair as an index of fetal exposure. And they followed those kids for up to 5 years to see if they develop any neurobehavioral problems. And they found that neither one of those had effects due even in the highest exposed group of women that had the highest concentrations in hair of 15 parts per million. So they concluded that 15 parts per million in women that are pregnant are still low enough to not cause problems on their unborn child. So that would be falling under the category of development studies, right? And they call that a no observed adverse effect level. Now notice that before we were talking about lowest observed adverse effect level because those workers had tremors. In this particular case, they use a population of women that never develop signs, neither in their offspring or the adults, of mercury toxicity. And the next thing was to find people that were smart enough to convert the levels of mercury in hair to concentrations of mercury intake on a day-to-day basis. And those people are from the world, were scientists, and this particular formula is found in a report by the World Health Organization of 1990. And the first thing, as you can see, what is remarkable is that mercury. These studies are so unique because they found that methyl mercury in hair correlates very well with how much is present in blood. And basically what happens is that if you were to take 1 centimeter of hair near the scalp, that would show up what the average concentration of mercury was throughout that particular month that the hair was growing. And as I said, mercury doesn't really move up and down much in blood, so it kind of tends to stay very stable. So they have a formula in which first they take hair samples, they use extrapolate how much equivalent is in mercury in blood, and then they use this formula to come up with the daily dietary intake of mercury. And as you can see, what are some of the what are some of the items that we have on that equation? We have the percent of mercury intake that is absorbed. Methyl mercury goes in very easily, about 95%. That's the estimate they use. And of that 95% that goes in, how much stays in blood? Well, only 5%. In other words, it doesn't like to stay in blood much. It moves into other tissues. And other parts of the equation were the volume of blood in the body. So basically, when you put everything into the equation, you come up with a daily dose of 0.067 milligrams per day. That's how much those women were ingesting throughout their pregnancy and still deliver babies that had no problems mentally. In order to make come up with an action level or a reference level that they can recommend. They divide that number by an uncertainty factor, and basically that uncertainty factor is 4.5, and that accounts for maybe the most sensitive people of the population that are not included in this study. So they come up with a tolerable daily intake for pregnant women of 0.015 milligrams per day, which is the same as 0.1 milligrams per week. Now this is for pregnant women, and if we go back, we'll see that for men is 0.3 milligrams. And as I was saying, fetuses are a lot more sensitive than adults. So basically they assume that if you're pregnant, you shouldn't be ingesting as much mercury as if you're just a happy camper like I am, or maybe hopefully you are too. And finally, I would just to end this presentation, I would like to make a proposal, and that would be to study what's happening in that bay where the Dagua River drains. And as of 2 years ago, in 2010, they were collecting some fish from the bay, blue striped grant, drums, sea bream, and these are parts per billion of mercury in those fish. As I mentioned, FDA has a cutoff point of 1 part per million. But remember, what's been released into that bay is elemental mercury, and sooner or later in the aquatic system that's going to be converted to methyl mercury. So it might be just a matter of years that these fish will build up higher concentrations of mercury. And here is a proposal that I would have for the future prevention of a mini-matter disease in Buenaventura. First, measuring mercury in fish in river sediments near the mouth of that river. And the criteria to select seafood for mercury analysis would be what position in the food web is that particular animal. And as we said, carnivorous will build up higher concentrations than planktivores. The age of the fish, the older, the higher concentrations. How about their movements within the water column? Do they stay in the same area? In that respect, we should probably select oysters, clams, crabs that stay in the same spot. Maybe when it comes to selecting fish, we could probably also take those fish that are mostly consumed by the local people in the area, obviously, and that would reflect maybe the make a better study if we're going to do a risk assessment of the risk of ingesting fish in that particular population of the area. Now, having said that, I know I have probably exhausted your patience, but if you have made it all the way to the end of my presentation, I hope I have delighted you. And having said that, I'm going to wrap up here, and I hope I have entertained you and said things that will make you a better person. So having said that, I'm going to dismiss you here and say goodbye. So be well, and see you soon.